Shared security responsibility model. This defines the security responsibilities of cloud service provider and the cloud service customer. The shared security responsibility in cloud is discussed in the context of cloud service models. Because every service that is offered by a cloud service provider belongs to one of the three cloud service models. The security responsibilities of cloud service provider and the cloud service customer differs with each cloud service model. On the screen, you have the shared security responsibility model. This outlines how security responsibilities are distributed between the cloud service provider and the cloud service customer in the different cloud service models. In some layers, the responsibility is shared between CSP and CSC. And in some layers, the CSC is exclusively responsible. And there are layers where the cloud service provider is exclusively responsible. Let's look into who is responsible for what at the different layers in the cloud service model in detail. Physical security layer. This layer defines the responsibility of physical security of data center, buildings, and other supporting infrastructure. Some of the aspects of physical security are perimeter security, defending the external boundaries of the data center by implementing fencing, gates, barriers, and restricted vehicle access. Access control, another aspect of physical security, restricting access to data center and other facilities by using biometric authentication, smart cards, and other access control measures. Surveillance, monitoring activities in and around data center and premises by using CCTV, security guards, or patrols. Environmental controls. This is another aspect of physical security. This ensures safety of physical environment by implementing fire detection, suppression systems, temperature and humidity controls to prevent equipment failure, earthquake and flood resistance in building designs. Asset protection. This is another aspect of physical security. This prevents theft, tampering, or damage to IT hardware. Inventory management, tamper-evident seals, and hardware disposal protocols to protect sensitive data helps in asset protection. Redundancy and disaster preparedness. This aspect of physical security ensures data center resilience by redundant power supplies, cooling systems, network connections, backup sites, and disaster recovery plans. The cloud service provider is exclusively responsible for managing, securing, and maintaining the physical security layer in all the cloud service delivery models. Storage layer. This layer has the storage devices such as hard disk, solid-state drives, non-volatile, memory express drives, storage area networks, network-attached storage, tape storage, and optical storage. Asset protection, access control, redundancy, and availability of storage device and systems are the security responsibility in this layer. The CSP is exclusively responsible from layer physical security to storage in all the cloud service models. Servers. A physical server is a hardware system designed to provide computing resources such as processing power, memory, storage, and networking capabilities. Asset protection, access control, redundancy, and availability of servers are the security responsibility in this layer. The CSP is exclusively responsible from layer physical security to server in all the cloud service models. Virtualization layer. This layer lets customer create a virtual rather than physical version of an IT resource, such as servers, storage, networks. It allows multiple virtual environments to run on a single physical hardware system by abstracting and allocating hardware resources. Let's discuss some of the security challenges in the virtualization layer. Hypervisor vulnerabilities. Exploiting unpatched or misconfigured hypervisors to gain unauthorized access to customer virtual machine. Denial of service attack. Resource overloading or attacks on the hypervisor will impact availability of the virtual machines and cloud services leveraged by cloud service customers. VM escape. This occurs when an attacker breaks out of the isolated environment of a virtual machine and gains access to the underlying hypervisor. From there, the attacker can potentially control other virtual machines running on the same hypervisor or compromise the hypervisor itself. VM hop. This occurs when an attacker moves laterally between virtual machines on the same hypervisor, without necessarily affecting the hypervisor. Data leakage. This is another hypervisor vulnerability. The inadequate isolation between virtual machines used by separate cloud service customers may lead to unintended data exposure. The CSP is exclusively responsible from layer physical security to virtualization in all the cloud service models. Next comes the OS layer. This layer is responsible for the operating system that gets installed on the virtual machine running on the hypervisor. Some of the security considerations when it comes to the operating system are: regularly apply OS updates and patches, use strong authentication and limit the use of administrative accounts for essential tasks. Restrict access and permissions by using the principle of least privilege. Use the built-in firewall to control inbound and outbound traffic. Use antivirus and anti-malware software to detect and remove threats. Perform regular scans to identify potential vulnerabilities. Secure network services by disabling unnecessary network services and protocols. Encrypt data to protect data at rest. Implement logging and monitoring. Hardening the OS by removing or disabling unnecessary applications, services, and features. Maintain backup and disaster recovery. In the infrastructure as a service model, the customer is responsible for securing the OS layer. In the platform as a service and the software as a service model, the CSP is responsible for securing the OS. Middleware layer. This is a software that acts as a bridge between different applications, systems, or components. Depending on the application requirements, the middleware component will be leveraged. On the screen, you have some examples of middleware components. Some of the security considerations when it comes to middleware are: enforce strong authentication. Middleware often handles sensitive data, making it a target for unauthorized access. Encrypt data. Middleware process, store, or transmits data. Sensitive data must be encrypted at rest and in transit. Misconfigurations. Default settings or improperly configured middleware components can be exploited by attackers. Supply chain risk. Middleware software from third-party vendors can introduce risk to the application and data. In the infrastructure as a service model, the customer is responsible for securing the middleware layer. In the platform as a service and the software as a service model, the CSP is responsible for securing the middleware layer. Runtime. Runtime components are all the resources, libraries, frameworks, and execution environments necessary to run the application after it has been compiled. Some of the security considerations when it comes to the runtime layer are: insecure dependencies. Third-party libraries or frameworks included in the application runtime may have unpatched vulnerabilities. Runtime configuration issues. Misconfigured runtime environments can create attack vectors. Runtime attacks on containerized environments. Containerized application runtime components might be vulnerable to container breakout attacks. In the infrastructure as a service model, the customer is responsible for securing the runtime layer. In the platform as a service and the software as a service model, the CSP is responsible for securing the runtime layer. The next layer in the shared security model is application. The application gets installed on the operating system, along with any runtime and middleware components on the virtual machine. Some of the security considerations when it comes to the application layer are security misconfigurations. Improperly configured servers, applications, or frameworks can create exploitable vulnerabilities. Insecure dependencies. Application dependencies, libraries, or frameworks with known vulnerabilities can be exploited. Insufficient input validation. Applications failing to validate or sanitize user inputs properly will make the application vulnerable to attacks. Unprotected. APIs without proper authentication, encryption, or rate limiting makes the application vulnerable. Denial of service attacks. Flooding requests to application, rendering it unavailable to legitimate users. Business logic flaws. Design or implementation flaws in application workflows that attackers exploit to bypass intended functionality. In the infrastructure as a service model, the customer is responsible for securing the application code. Any middleware and runtime components installed on the operating system. The customer is responsible for the application layer in the infrastructure as a service model. In the platform as a service model, the customer is responsible for securing the application code. The CSP is responsible for securing the underlying platform, which includes virtual machine, operating system, middleware, runtime, and other platform services. The CSP also offers tools to enhance application security. In the software as a service model, the CSP is responsible for securing the application code and the underlying platform, making the CSP responsible for securing the application layer. The next layer in the shared security model is networking. In the infrastructure as a service model, the CSP secures the physical networking devices such as leased lines, routers, switches, and cables in the CSP's data center, secure virtualized network infrastructure such as virtual private cloud or VNets for the customer, ensure there is network segmentation and isolation between customers, offers managed DNS services, load balancing, and traffic distribution tools, provide tools for monitoring network traffic and generating logs. The customer is responsible for configuring the virtual network resources, such as subnets, routing tables, and peering. Configure DNS records, load balancing policies, and SSL termination settings. Configure and analyze network logs and set up alerts for unusual activity. Ensuring only authorized people has access to the virtual network. Restrict inbound and outbound access to network using network access controls. Encrypt network communication by using transport layer security. In the platform as a service model, the CSP is responsible for securing all of this. The customer is responsible for configuring and securing application-level networking, such as secure API communications, secure communications by encrypting data in transit, traffic management and routing, usage of load balancers to control how requests are distributed between application, leverage web application firewall to help filter and monitor HTTPS traffic to protect against attacks like SQL injection or cross-site scripting. In the software as a service model, all the responsibility mentioned in the infrastructure as a service model and the platform as a service model becomes the CSP's responsibility. The next layer in the shared security model is data. In all the cloud service models, the customer is legally responsible for the data. In other words, the customer, being the data owner, is responsible for protecting the data, not the cloud provider by law. In the infrastructure as a service model, the CSP is responsible for the physical security of storage devices, offers services to encrypt data at rest, in transit, and in use, provide IAM and storage access policies, offer backup services or tools for creating snapshots and disaster recovery, offers tools for logging and monitoring data access and usage, ensure cloud infrastructure complies with industry standards such as SOC 2 and ISO 27001. The customer is responsible for data classification and lifecycle management. Encrypt sensitive data, configure IAM roles and policies to control who can access data, configure data retention, backup, and recovery, monitor data usage, suspicious activity, or unauthorized access, provision, configure, and secure storage services, configure TLS for secure data transfer between cloud services, ensure compliance such as GDPR, HIPAA to meet business requirements. In the platform as a service model, the CSP and the customer shares the security responsibility. The CSP is responsible for the physical security of storage devices and underlying physical infrastructure where the data will be stored and processed. The CSP provides, manages, and secures the database, storage services, and is responsible for availability, scalability, patching, and updates to the database and storage services. The customer is responsible for securing their data stored on the database and storage services, configuring scaling parameters, and when to patch or update the database. Most of the platform as a service offerings of database and storage services provide automated backup. The customer is responsible for configuring, retention, and other backup policies. The CSP provides disaster recovery based on the options selected by the customer, availability zones, or at the regional level. The customer has to choose the disaster recovery based on business requirements. The CSP provides default platform-level encryption for database and storage services. It is up to the customer to use application-level encryption, customer-managed, and bring-your-own keys. The CSP provides cloud services that are certified for industry regulations such as GDPR, HIPAA, but it's the customer's responsibility to ensure data compliance with industry regulations. The CSP provides IAM tools. It's the customer's responsibility to implement proper IAM policies, settings, and access controls. In the software as a service model, the CSP, or the software provider, is responsible for securing the underlying infrastructure, platform components, and application code. Provide encryption by default. The CSP ensures high availability of data and disaster recovery, and provides limited backup. The customer is responsible for the data. The customer must configure backup retention policies and perform additional backups if needed, managing access to data, protecting data through configurations, policies, and any compliance settings. Configure security settings for the application. Make use of customer-managed keys if the software provider permits. Implement data loss prevention to protect data. The next layer in the shared security responsibility model is identity and access management. The responsibility of identity and access management is shared between the customer and the CSP in all the cloud service models. The CSP provides functionalities like users, roles, access control policies, multi-factor authentication, API access and authentication, logging and monitoring. The customers can use the identity and access management functionality offered by the CSP to secure the cloud services, application, and data, or leverage a third-party vendor that provides identity and access management functionality. The next layer in the shared security responsibility model is configuration. The number one reason for security breach in cloud is misconfiguration of cloud services. An AWS S3 bucket containing sensitive data that is exposed to the internet, or a database service that allows anonymous logins, are some of the examples. The customer is exclusively responsible for securing the configuration layer in all the cloud service model. With this, we wrap up the shared security responsibility model.